Sal talks about the immune system. Sal is a boy and he loves to learn everything health related. Recently, he got sick and he learned about the different pathogens that can infect the body. Now he wants to know how the body can fight back disease. So, what is the immune system? Previously, you heard about the infectious diseases. The immune system is the name of the organs that fight back against these invaders and prevent your body from getting sick. So, what does the immune system include? It is a complex network of cells, tissues, organs, and substances they make that help the body fight against infections and other diseases. The immune system includes white blood cells, organs, and tissues of the lymph system, such as the thymus, spleen, tonsils, lymph nodes, lymph vessels, and bone marrow. So, how does the immune system work? Immune System Part 1: Non-specific response. Your body has external protection from these pathogens, like your skin. We call these the first line of defense because they are the first in line to dispel the pathogens. The mucus in your nose, eyes, ears, and other cavities are also part of this external protection system because they all block the pathogen from getting inside your body. The first line of defense prevents the pathogens from getting inside the body. However, this is not foolproof and sometimes the pathogens do get in. In this case, you call up the gobblers. The second line of defense includes the inflammatory response. When, for example, Sal got a cold into the body past the mucous membrane defense system, mast cells will come here to produce an inflammatory response. They are responsible for allowing blood vessels to dilate and allowing many types of white blood cells, cells that fight infection, to come to injury sites. Macrophages, also part of the second line of defense, are the gobblers. They engulf and digest the pathogen. They can also be triggered when the complement system of the immune response produces factors that attract macrophages to the injury site. After all this gobbling and signaling, the infected area can return to normal. However, that was a non-specific response. It just came and ate the pathogens regardless of what and where it was. However, what happens when we don't need the whole immune system to go haywire? What if, for example, we get a cold virus? We don't need immune responses happening in the blood and the skin, we only need it in the nasal, ear, and mouth cavity. This is what is called as adaptive immunity. The pathogens mostly all have antigens, things that the human body identify as non-self. This is when we use the third line of defense. There are two responses that adaptive immunity follow: cell-mediated and humoral. Cell-mediated response is when the cytotoxic T cell shows up, which is a white blood cell with the ability to destroy cells that have been infected with the pathogen. It does this by prompting the infected cell to kill itself. This then also destroys the pathogen. But sometimes there is another way to stimulate cytotoxic T cells. Remember the gobblers, the macrophages that have the pathogen inside of them? Well, they also stimulate the cytotoxic T cells to look for the pathogens with a certain antigen to kill. They do this by calling another type of cell, the helper T cell, to come look at the antigen and then lastly stimulate the cytotoxic T cell to come and kill the infected cells. Remember the helper T cells now? They are big helpers because they not only help the cell-mediated response, but also the humoral response. In the humoral response, the macrophages with the antigen can attract helper T cells to bind, and these helper T cells can stimulate another type of cell, the B cell, that releases proteins known as antibodies to bind to antigens and deactivate the pathogen from working, in turn basically killing it by reducing its ability to move, reproduce, or infect. The binding between an antigen and pathogen can also be a sign to tell macrophages to come and eat it. Therefore, macrophages can play a role before and after adaptive immunity. Now, another common point that both cell-mediated and humoral responses have is that they keep memory cells, memory B and memory T cells, so that if the same pathogen invades again, the immune response would be faster and more efficient. This is why vaccines work, because by exposing the body to a weakened or dead strain of the virus, the memory cells can fight the real one much faster, making the immune response more efficient. All this investigating is making Sal tired, and he can't wait for his immune system to work even faster.